Now we go to exercise 6.2 here, which is about inequalities here. This is about inequalities in two variables here. So to draw these inequalities in two variables, you need Cartesian plane here. Cartesian plane, remember, that is about x-axis and y-axis, which is sometimes called two-dimensional plane here. So we represent inequalities in this exercise 6.2 in two-dimensional plane, remember here. Earlier in the 6.2 exercise you had inequalities in a single variable, so you were using straight line only. Here we use two coordinate axes, that is x-axis and y-axis, because everywhere you would be having two variables, x and y. So let's see the first question here. Question number 1 is here, x plus y less than 5. Now what's the meaning of this? You get all possible values of x and y for which x plus y is strictly less than 5, right? And graphically, remember, to list all these values, it's not easy task, so we'll just show it graphically in two coordinate axes, that is in a Cartesian plane. So for that, what we'll do here, I'll consider x plus y equals to 5. Now you know that this is a straight line, I mean linear equation. We did it in relations and functions. Straight line means it's a linear function, if you remember. And every linear function, represent a straight line. So graph of this will be a straight line. Okay. Now how do we draw a straight line? If you recall from that chapter or from 9th standard, you need minimum 2 points which satisfy this. So I'll prepare a table. We were doing such things in drawing of graphs, if you remember. X, you can choose any value. Suppose I'm taking 0. Then what is y? It would be 5. Next, you can take anything. I'll take 1. You can take 2, 3, 4, whatever you want to take. I'll take x equals to 1. Then y would be 4. You need minimum 2 points, remember. So one is 0, 5 and the other one is 1, 4. You can take 3, 4, 5, as many points you wish. But for straight line, 2 points, 1 and 2, 2 points gives you the final graph, remember. If you have any other function like quadratic, trigonometric, then you need more points. But for straight line, 2 points are sufficient, remember. So in such exercises, whenever you are drawing a straight line, we just take 2 points. So I have chosen 0, 5, 1, 4. You can take anything else. Final graph will be same, remember. Don't worry about it. So I'm just showing now two coordinate axes here. So let me draw two coordinate axes here. This is x-axis here. And then I have here y-axis. This is y-axis here. Let me show like this. So you have 4 quadrants here. Now here you have origin, here you have 1, 2, 3 and so on. Here you have 1, 2, 3, 4, 5, minus 1, minus 2, here 1, minus 1, minus 2 and so on. Okay, this Now we represent these points in the Cartesian plane. Which point? 0, 5, x, y. 0 from here and 5 from here. 0, 5. 1, 4. 1 from x-axis and 4 from y-axis. 1 from here, 1 from here. Okay. Now you can draw a unique line, I mean a straight line through these 2 points. But remember, here I have strict sign, so I'll draw the dotted line, remember. So here I'll just draw the dotted line through these 2 points. I'm just drawing a dotted line through these 2 points. Use foot ruler while drawing. You can draw in your class book only. No need to use the graph paper, remember. So I'm showing. Okay. Why I'm showing by dotted lines? Because dotted points. Why I'm showing dotted line using dotted points? Because I have strictly less than sign. If you remember, in single variable, if you had something like this or like this, then you were using open interval. If you have like this or like this, then you were using close interval for a straight line, if you remember. But when we have here strict inequality, then we use such a dotted line, remember. Now you want all points for which summation is less than 5. Now because of this dotted line, the entire plane is divided into two parts. This whole plane is divided into two parts. One is this portion, one more is this portion. This is a line, remember. This is a line. So one portion is this, the other portion is this. The entire plane is divided in two parts, this part and this part. Now the solution of all xy, whether it would be this one or this one, that we need to decide. So how do we decide this? You choose any point randomly. So normally we take origin. Not necessary because that's easy. What are the coordinates of the origin? You know 0, 0. Now check whether 0, 0 satisfy this equation or not. So 0 plus 0, you know it is less than 5. So 0, 0 satisfy this inequality and it is on this side. So therefore this region is the solution of the given inequality. Entire this region. What's the meaning of this? This half plane is a solution means what? Every values of x and y from this satisfy this inequality. You pick up any xy from this. Suppose I have taken this point. Can you tell me coordinates of this? -2 and 2. This point, x coordinate -2, y coordinate is 2. Put there, what will get? -2 plus 2, which is 0, that is less than 5. It is satisfied. But no point from this would satisfy that equation, remember. You take any point from this portion. Take any point from this portion. It will not satisfy this inequality. Suppose I have taken this point randomly. Let's take this here. Suppose x coordinate is here 5 and y is also 5. 5 comma 5. It will not satisfy this. 5 plus 5 is not less than 5. So this is not the solution. This is the solution. Fine. Every time you have to do this. Draw the graph. Decide the region. Finished. Whether it is this half plane or this half plane. That's what all in all about the solution. Let me go for one more question here. Question number 2, second question. 2x plus y is greater than or equal to 6. Okay, so first I'll consider 2x plus y equals to 6. You know that this is a straight line. We decide 2 points here. Prepare a table as we are doing in trigonometric functions and so on. Take x equals to 0. What is y? 6. Take x equals to 1. So y would be 4. 2 points. 2 points are sufficient because you are drawing a straight line, remember. Again I'm emphasizing, if you are doing any other function like quadratic or cubic or trigonometric functions, then 2 points are not sufficient. As it is a straight line, therefore minimum you need 2 points. You will get the unique straight line through the given 2 points. Not necessarily always you should take 0. You can take anything, but normally 0 and 1 gives us easy graphs. Graph would be same, remember. So now I'm just drawing as I did in the previous question. So this is the x-axis here. Okay. This is y-axis here. Now I'll present the points roughly. So here 0, this is 1, 2, 3, 4 and so on. You know here -1, -2, -3 and so on. Here 1, 2, 3, 4. Here you know -1, -2 and so on. Okay. Now we we present these points in the Cartesian plane. Which point? 0, 6. 0 from here and 6 from here. This is 5 and this is 6. Roughly. 0, 6. 1, 4. So 1 from here and 4 from here. So this is 1 4. Now we get a straight line through these 2 points. Now here we have greater than or equal to, so we'll not draw the dotted line, remember. Okay, we draw the line like this. In the previous question it was strict inequality, so you had a dotted line, you had a line like this. Now like the previous question, the entire plane is divided in how many parts? 2 parts. One is this part and the other one is this part. Now the solution set is this or this, that we are going to decide. So what we do for that, as I told you, we take any one point. Normally we take origin. Origin लेना जरूरी नहीं, आप कोई भी ले सकते हैं. I'll take origin. Put here. So 0 plus 0, where I'm putting? In the inequality. 0 plus 0 greater than or equal to 0. Is this true? This is not true. That means 0 0 doesn't satisfy this inequality. That means this is not the solution. So where is the solution? The upper half plane. The solution would be the upper half plane, this portion. This is the solution. All points from this portion, this upper half plane, satisfy the above inequality, remember. I've checked for 0 0. You can see that the 0 0 doesn't satisfy the given inequality. That means this is not the portion. So then which is the portion? This one. Every point from this portion would satisfy that inequality. Take any point from this region. So randomly, suppose I'll take this 4 4. 4 from here, 4 from there. You check, it would satisfy. 2 into 4 plus 4. 8 plus 4 would be obviously greater than or equal to 6. So this is the solution side. I hope this is clear to you. Fine. Fourth question. Y plus 8 is greater than or equal to 2x. Okay. So this is also a straight line. What we do? We just imagine equals to y plus 8 equals to 2x. Okay, now we need to represent this straight line. We need minimum how many points? 2 points. So here I prepare a table for values of x and y. I'll take x equals to 0 for example. So y would be minus 8. So 1 is 0 comma minus 8. X is 0, so y is minus 8. Okay. Next, you can take anything. Suppose I'm taking x equals to, let's take 4. Randomly I'm taking, remember. If I put 4 here, so 8. So y will be 0. So other point is 4 comma 0. Remember, any 2 points you can choose. First I have taken x equals to 0, so y would be minus 8. So 1 is 0 comma minus 8. 0 comma minus 8. Next I have chosen x equals to 4. You can take 1 also. This is not important. I have placed 4 here and get y from this. If I put 4 here, 8 y on the other side. So 8 on the other side. So y equals to 8 minus 8, 0. Okay. Now you have 2 coordinate axes here. You use foot ruler, remember, in your class book. X-axis here, x-axis, then this is y-axis. Okay, now I'll just show the points here. This is 0 2 4 6. I need minus 8, remember. This is here 2 4 6, here minus 2 minus 4 minus 6, minus 2 minus 4 minus 6 minus 8. Okay, now first point is 0 comma minus 8. So 0 from x-axis and minus 8 from y-axis. So this point 0 comma minus 8. 0 from here, minus 8 from here. 4 comma 0. So 4 from x-axis and 0 from y-axis. So here 4 and y is 0. So 4 comma 0. You know it's on the x-axis. So you have 2 points. Now there is a unique line through these 2 points. Here you're greater than or equal to, remember. So we'll not have dotted line, we would be having line like this, remember. There is a line. Okay. Okay. This is the equation of which straight line? Y plus 8 equals to 2x, equal to, remember. This represent which straight line? Y plus 8 equals to 2x. Or this is the graph of y plus 8 equals to 2x. We did it in functions chapter. Okay. Now next point, we decide the region, whether this is the required region or this is the required region. This half plane or this half plane. So what we do, we normally take origin here, 0, 0. Put into the given function, given inequality. So I'm putting there 0 plus 8 greater than or equal to 0. Is this true? 8 is greater than or equal to 0? No, this is not true. 8 is greater than or equal to 0? Not true. That means this is not the required region. So this would be your required region. Every point from this region satisfy the given inequality, remember. Every point from this region would satisfy that inequality. I've chosen 0, 0 from here. It doesn't satisfy. So this is not the required region. This is the required region, remember. Take any point from the shaded portion. It would satisfy the inequality. Suppose I've taken this point. What are the coordinates? Minus 6 and 6. Minus 6 and 6. I'm putting into the inequality. What is y? 6 plus 8 is greater than or equal to here minus 12. And this is always true. 14 is always greater than or equal to minus 12. So this is correct, remember. This is the required region. Half plane. This half plane satisfies this inequality. Not only this, there are infinitely many points. Every point from this half region would satisfy the given inequality. I hope you are clear with this now. The question number 9. Y is less than minus 2. This is the inequality. X variable is absent there, remember. Okay, so what we do here, you can imagine like y equals to minus 2. So y is fixed here. If you prepare the table here, you can choose anything as the x. Suppose I take x0, y minus 2. If I take x1, y minus 2. Every time here, every time x is fixed, remember. Y is fixed, minus 2, minus 2. X you can choose anything. If I take even x2, y is always fixed, minus 2. We need just 2 points. So I'll draw a straight line here. So first we have the x-axis here. Then there's y-axis, you know. I'll just show the points here. This is, you know, here origin 0, then you have 1, 2, something like this. Here you have minus 1, minus 2, minus 3. Here you have 1, 2, 3. Here you have minus 1, minus 2. First is 0, comma minus 2. So 0 from here, minus 2 here. 1 minus 2, 1 from here, minus 2 here. If you want one more, 2 and minus 2, so this point. You need minimum 2 points, just have shown 3 here, remember. So there is a straight line through these 2 points, that is this. And you have strict inequality, so you must have a dotted line here, remember. That means the points on the line are not included. In single variable, you were using open interval. Here we use the dotted line. That means points on the line are not included. Okay. Now, you have two half planes. This upper half plane and lower half plane. So whether this is a solution or this is a solution. Just look at here. Y should be less than minus 2. This is y. Y का वैल्यू माइनस 2 से कम होना चाहिए. कहाँ पे? इधर नीचे. So this is your required solution. y का वैल्यू x वेरिएबल यहाँ पे कोई भी हो सकता है, पर ये पोर्शन में y का वैल्यू -2 से कम ही है. रिमेंबर, every point from this region satisfies this inequality. Points on the line are not included, that's why we have dotted line. You know that any line parallel to x-axis, that's called the horizontal line. This is actually horizontal line. Horizontal line, if you remember, we'll see it. We have one chapter about straight lines. Horizontal line here, remember. So this is the required solution. Every point from this here, x coordinate can be anything. Suppose I have chosen this point roughly. So x coordinate may be 4, but what about y coordinate here? Here you see y coordinate would be, let's take -4. So this is 4 comma -4. You can see that it would satisfy this inequality because here y का value -2 से कम होना चाहिए, which is -4. So this is your required solution, lower half plane. This every point from this satisfies the given inequality, remember. Okay. Next, let's see this 10th question. There x is greater than -3. Y variable is absent, see here. So here, if I consider equals to -3, so you can choose here any value of variable y, but x is always fixed. -3, y can be anything. Suppose I have taken 0. Next, x is fixed here, -3, y can be anything. Suppose I have taken 1. So you have 2 points, and now we represent these 2 points in the Cartesian plane. Okay, so let me show this here. This is a straight line here. X-axis, y-axis, as we know, as we did number of times earlier. This is 0, 1, 2, here 3, -1, -2, -3, here 1, 2, 3, here -1, -2, -3. Okay, now let's represent these ordered pairs. -3 then 0, so -3 from x-axis and 0 from y-axis. So this point, -3 and 0. Then -3 and 1, -3 from which axis? X-axis, and 1 from y-axis. So this point. So you have line like this, parallel to which axis? Y-axis. Okay, so like this. And here you have greater than, that is a strict inequality. So I'll show the dotted line here. Like this. Okay, now as we did earlier, we decided the region. Whether region will be this or this, right half plane or left half plane. यहाँ पे तो क्लियर है, x का वैल्यू -3 से ज़्यादा होना चाहिए. So where you have value of x more than -3, right side obviously. So this is the required solution. ये पूरा plane जो है, this would satisfy the given equation, given inequality, remember. Dotted line means points from the line are not chosen. It's like an open interval. It's a open interval जैसा. Every point from this region would satisfy the inequality. यहाँ पे आप कोई भी x and y choose करेंगे तो y could be anything, but x का value -3 से ज़्यादा ही होगा. You choose anything. Your x is more than -3. So this right side half plane is the required solution of the given inequality. Okay.